Across the globe, people set varying standards for all kinds of day-to-day practices. People have different ways of dressing, eating, worshiping, and working. Even the way people use cars varies from country to country. Today, most of the modern world has written laws for car usage safety protocols. Many countries have official laws that encourage people to use seatbelts, but not all countries enforce these laws the same ways. A survey conducted by the Harvard School of Public Health surveyed people from over 30 countries, and 57.7% of respondents said that seatbelt laws were not being enforced very well. While we respect the beauty and diversity and recognize that different living conditions lead to different social standards, we are attempting to make a case to encourage all countries with loose seatbelt enforcement to consider stronger seatbelt advocacy. As an example, we found the results of research that was done by Salim and Salima that compares child death rates between the countries of Oman and the United Kingdom. A child in Oman is 42 times more likely to die in a car crash than a child in the UK. This is a staggering statistic considering Oman has a population of 3 million people, whereas the UK has a population of almost 65 million. The main reasons for these child deaths is improper seatbelt use or a complete lack of seatbelt use. And this is just one of many examples that we found. Other countries such as Turkey and India are also notorious for loose seatbelt usage. The leading causes of death in motor vehicle accidents is trauma to the head or spine. Someone who is not wearing a seatbelt is twice as likely to die in an accident as someone who is wearing one. Something as small as a seatbelt could be the difference between life and death. Using dynamics, we can prove that seatbelts have a profound impact on the force that a body feels during a crash.
Our assumptions for this problem are the mass of the child is 28.5 kilograms, the car is traveling at 90 kilometers per hour, the time it takes the child to stop without a seatbelt is 5 milliseconds, and the seatbelt adds 15 milliseconds. There's no braking involved, and the car hits a stationary object. The equation for linear impulse is the mass of the object times its initial velocity plus the force over a period of time equals the mass of the object times its final velocity. The mass of the child, 28.5 kilograms, is multiplied by 90 kilometers per hour, which is also 25 meters per second, and is added to the force over 5 milliseconds. The right side of the equation equals 0 because the velocity of the car is 0 at the end of the 5 milliseconds. Isolating the force on the right side, the equation can be solved for 14,250 newtons of force acting on the child during the crash. Using this force and dividing it by the mass of the child times gravity, the g-force comes out to be 51 g's. With this g-force, a 9-year-old child would almost certainly die. Now, the same equation for linear impulse is carried out to find the force on the child with a seatbelt on. But let's say that the seatbelt adds 15 milliseconds onto the time it takes the child to stop. This results in a much smaller force of 3,562.5 newtons acting on the child, which comes out to a g-force of around 13 g's. In this case, the child may still be seriously hurt, but the likelihood of him or her dying has decreased by a lot. In conclusion, seatbelts save lives, and it should be a top priority of people everywhere to ensure proper education on the risks of not wearing seatbelts and how to wear them correctly.